Hello everyone, my name is Himanshu Tiwari, final year student, Department of Civil Engineering, Faculty of Engineering and Technology, University of Lucknow. I am going to present seminar presentation on the topic of application of GIS data and remote sensing for groundwater study. Here is my table of content. Moving to the first, aim of the module, importance, introduction, what is GIS, what is remote sensing and GIS technique for groundwater study, methodology, groundwater and land surface, image interpretation for groundwater study, case study, conclusion. In next slide, aim of the module. Understand the interaction of groundwater and land surface, understand the occurrence of groundwater in different terrain, to apply remote sensing and GIS technique for hydraulic potential and flux to explain conceptual model for groundwater flow system. Moving to the next, here is importance. In importance, basically we are going to explain the remote sensing and data can provide data of movement and occurrence of groundwater in groundwater system. The factor which controlling the groundwater system which can be determined. Remote sensing data helps to give details of hydrogeological, geophysical investigation on the ground before actually drilling for quantitative assessment. Give the idea about the aquifer present in the rock. It is helpful for proper management of groundwater resource. Example, it prevents an over exploitations and helps to monitoring of groundwater in area. Selection of suitable draining area for groundwater. Introduction. This module is divided into two parts. First part deals with the application of remote sensing and geographical information system GIS technique for the groundwater study. Groundwater is a vital natural resource for mankind. This resource is extensively being used for drinking and household utilization, such as irrigation and industrial purpose. It plays an important role for the economic development and food security of the country. Only 2.5% of the earth's water is available as fresh water. Demand of groundwater is increasing day by day due to rapid increase in population, urbanization, industrialization, and agriculture. It leads to decline in groundwater level and anthropogenic activity, deteriorating the quality. Similar problems are also prevailing for the usable surface water. Hence, it is important to study the groundwater potential and its quality of our country for a better sustainability. Groundwater modeling and management require a level input data, which is most of the time difficult to obtain. Additionally, this method is expensive and time consuming. So the remote sensing and GIS technique provide ample scope to generate input data to study groundwater and its quality of an area more efficiently at lower cost and time. Moving to the next slide. What is GIS? Basically, GIS is a system of capturing, storing, checking, integrating, manipulating, analyzing, and displaying data. Are especially referenced to the basically data presented by the GIS in two types, especially and non-especially. Especially data is such that like boundary, walls, and such a land surface, and non-especially data is example such as population and etc. In here, GIS present the data in especially reference to that. This normal considered to involve a specially reference computer database and appropriate application software. What is remote sensing? Remote sensing, the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with the object, area, or phenomena under investigation. It means about information about any object or area without being in physically contact with it. This is done by remote sensing and regarding reflected or emitted energy and processing, analyzing, and applying that information. Remote sensing and GIS technique for groundwater study. Remote sensing provides information in space, time, and GIS technique helps to store, interpret, and retrieve spatial data. It is very essential for an SSPL area. This technique is very successful for a surface hydrology. But for subsurface hydrology, remotely sensed images such as aeroborne and spaceborne, passive or active microwave image data from specific satellite sensor with a different spatiotemporal or spectral resolution can be analyzed to infer the groundwater behavior from surface expression and its quality. For preparation of groundwater model of an area, Surface water treated as the boundary condition for the subsurface flow equation, which is based on the Darcy law. Darcy law is basically velocity V is directly proportional to hydraulic gradient. Hydraulic gradient means head loss per unit length. Remote sensed images are used to define boundary conditions such as stream, lakes, wetlands, seepage areas, recharge zone, or evapotranspiration zone for prediction of groundwater flow. Moving to the next slide, remote sensing provides information in space and time, and GIS technology helps to store, interpret, and retrieve spatial data. It is very essential for an accessible area. Generally, these data are combined with the numerical modeling, GIS, and ground-based information. The basic principle for the remote sensing and groundwater is to find out the 5 environmental science and remote sensing and GIS application. In environmental science applications of remote sensing and GIS in groundwater and water pollution study, shallow groundwater flow. These flow are driven by the surface forcing and other geological parameters which can be inferred from the surface data. Moving to the next. Here is the image flow of groundwater and aquifer and hydrological cycles. In flow of groundwater and aquifer is basically explained by the figure high hydraulic conductivity, low hydraulic conductivity aquifer. Hydraulic conductivity basically represents the permeability. Permeability is the vertical flow of the water through in the soil, which is known as the permeability. And here is the presentation of this hydraulic conductivity high and low and very low clearly. And in the hydrological cycles, how the movement of the groundwater, evapotranspiration, precipitation, observation wells are, and how the unconfined aquifer, confined aquifer, how vegetations cover are by plants which recharge the groundwater through the infiltration of the water. Moving to the next. Methodology. In methodology, the rate and behavior of flow depend on the geology, and it can be expressed by the Darcy law. Darcy law defines the flow of fluid in porous medium and also state that there is a linear relationship between flow velocity and hydraulic gradient, which is D is directly proportional to I. I is the hydraulic gradient. For a given saturated soil or medium under steady laminar flow condition, it can be started as Q is equal to Ki, where Q is the specific discharge vector representing flow per unit area. K is the hydraulic conductivity, which is function of geology. I is the hydraulic gradient, head loss per unit length, which is a function of surface forcing. Geology map, geological maps are prepared in the combination with the remotely sensed data, and ground verification provides useful information about the hydraulic conductivity, water-bearing information, alignments such as faults, fractures in the rock terrain. This information is used for groundwater prospecting as evident from literature. Moving to the next, here is the flow chart. In flowchart, steps are be explained. First, aerial photos collection, then aerial photo analysis. In analysis, we are geological interpretation, alignment interpretation, land use interpretation. After this, GIS processing. In GIS processing, we are digitizing and building database. After the derives maps from the processing, we derive the maps of obtaining of land use, slope, drainage density, lithology, alignment density. After this, we spatial analysis. After spatial analysis, we groundwater potential जो आप prepared, map prepared. And here is the graph of total head of groundwater, head loss of groundwater. In total head of groundwater is the how the movement of the groundwater through the pervious soil between two impervious layer of the soil. And in this, I also explain the to how it is total head. And in this next figure, head loss of groundwater. Head loss of groundwater is represented by the hydraulic gradient. Hydraulic gradient, which is explained through the head loss per unit length, which is HP minus HA upon dx. Moving to the next, groundwater and land surface. Surplus water after evaporation infiltrates the surface and recharges the groundwater table. In this case of movement of water, which water is reversed while comparing with the discharge of groundwater discussed in the previous section. Growth specification and abundance of vegetation of a region is dependent upon the availability of water and nutrients, atmospheric moisture content, salinity and acidity, alkalinity. Different plant species provides due to occurrence of groundwater, and but the link between them varies considerably in different climatic regime. Soil chemistry also play a major role to support selective plant species. Hence, while considering the vegetation species assembles to study the groundwater condition, and soil chemistry should be taken in consideration. Distribution, growth, and types of plant are used as an indicator in remote sensing and GIS method to determine the groundwater table. It explained that how surplus water after the precipitation, surplus water infiltrates the ground through the soil, which is recharge the groundwater. And if we increase the surplus water infiltration to the ground, we provide a vegetation cover such as like the plant through the maximum infiltration of water in the ground, uh, maximum infiltration of water through the soil. Moving to the next, here are the zone of model, Vadeo zone model, overview of Vadeo zone model. Different model have been used in soil or combination to predict movement of groundwater. Combination of water table dependent Vadeo zone model. In Vadeo zone model is basically explain the unsaturated soil. How is the flow of groundwater? Vadeo zone model is basically known as the unsaturated soil, such as capillary fringe, in which capillary fringe are existed. And overview of heterogeneous model is how explain the confining impermeable between impermeable layer and purge water table. Moving to the next. Image interpretation for groundwater study. Remote sensor image depreciate the terrain and sometimes provide the valuable information about the subsurface geology. Hence, interpretation of these images for extracting information about the groundwater required expertise and background knowledge about the terrain. Same geological formation may appear differently in the image due to local weathering condition, erosion or accumulation or sediment, debris. Sometimes vegetation cover marks the outcrop. Hence, field verification are required. Image interpretation are generally gets validated using fieldwork, geological map, geophysical, and drill hole data. Hydrological image interpretation of different geological terrain required basic understanding of the geology of that terrain. It means we if we are moving to the interpretation of the image, we should have basic knowledge about this terrain. How we are going to this process. Terrain consists of unconsolidated sediment, mostly the quaternary deposits have been extensively studied for a groundwater exploration, withdrawal and management. Moving to the next, here is the image interpretation. How image interpretation will be happen such that aerial photograph, through aerial photograph. In aerial photograph, basically detailed explanation of the terrain, geological terrain, in which how evaporation uh, and precipitation happen through the ocean and condensation, transpiration through the plants, runoff of water through the soil, infiltration through the soil in the groundwater, recharge the groundwater. Same things will be happen from lakes, and here the how the extraction of snow and ice or melting of ice and sublimation and precipitation of ice also. Moving to the next. Here is the case study. Application of GIS and remote sensing in Visakhapatnam, India. In Visakhapatnam, the tribal people of agency area in Machkund River catchment of Visakhapatnam district, Andhra Pradesh, mostly dependent on the spring for their water requirement. As the sources are depleting at a faster rate, an immediate need for exploration of potential groundwater zone was felt to meet the demand. And this study, remote sensing and geographical information system, GIS-based groundwater potential zone map have been carried out in that area. The percentage of influencing factor of the ninth thematic layer has been calculated using analytical hierarchical process, that the problem can be resolved by this process or this system. In case study 2, application of GIS and remote sensing in Maharashtra. In Maharashtra, remote sensing and GIS technique provide more reliable and accurate estimation, and it is very helpful application for hydrogeological investigation. In Maharashtra, Deccan basalt behave diversely. in different geological setup. Hydrological framework of aquifer and structure evaluation in the Deccan study by Elker. Here is the conclusion. Conclusion: the first part of the module deal with the application of remote sensing and geographic information system technique for groundwater study. In the first part is written for those who are interested in applying this technique for groundwater study, be it exploration, evaluation of resource management, or required data processing. Inadequate experience in image interpretation, lack of knowledge will hinder the appropriate use of the satellite image and aerial photograph. Thank you.